So when we talk of entanglement, we can say that it is expressing the definitive and mathematically deduced interactions between both end surfaces and the infinite interactions occurring between their virtual interiors. So we're seeing entanglement here. I'm using the term interactions. In essence, it's a term that can apply also to entanglement. Interaction, entanglement, however you want to put it, is the same principle. So I've explained that literally the surfaces of the manifolds are interacting due to the fact that one side is sending information to the other via the recursion of information. And this interaction between the manifold surfaces, black hole surfaces, the surface of one eye as directly entangled with the surface of another eye, it can be applied in many different ways, that one side is sending information to the other. They're interacting. So all different vibrations that occur on either side are explicitly described as occurring within their interiors and not on their surfaces. Again, the surface flow of information is defined as merely a light ring expanding or contracting uniformly across a one-dimensional surface. And if we put this into an analogy, we can start seeing that the relationship as being described now as one continuous string, despite that string is broke down into component parts of a static surface here, a static surface here, a beginning of point of a string here, a beginning of a point of a string here, due to their entanglement producing infinite recursive. And all of those component parts of the static closed aspects of the strings on both sides is being birthed due to the relativity of those 2 points as reflecting the volume of information on the open part of the string. So in essence, we can take the whole of the string as described and as depicted as being a long row of same information where the open part of the string, the information of the open part of the string, is found at every point to the right and is found at every point to the left. Therefore, the quantum particle, whatever you want to refer it to of, is actually found everywhere along the string. We can take that analogy as referred to a timeline or a time measuring one way and time measuring the other, and we can actually refer to it as curving around, and then we can get into the spherical or torus relationship. Actually, this can kind of be understood if you take two mirrors and have them parallel to each other, exactly parallel, their reflective faces, and you look down or through one mirror into the virtual recursive matrix, then you'll see that the membranes are straight, and that each membrane falls on the z-axis, which represents the center of the information on the surface. If you have a light ring on the surface, the center of that light ring is basically the timeline that's going down into the virtual matrix. And on that z-axis, or on that timeline, is stationed individual slices or membranes of information that's reflecting the same circle from the surface. So in essence, if you have, let's say, the infinite row of membrane is here, and the big row is up here, then as these recursive membranes go closer to the surface, both will contract. This will be contracting horizontally on the surface. This will represent the contraction of the timeline, the shortening of the timeline. So not only will the timeline, once it finally gets to the surface, end up as representing this circle on the surface contracting to its center, all other circles also are contracting to their center as they come up, as they go toward the surface. So each individual slice or membrane found in a recursion is centered with the main wave we can refer to on the surface. We have a main wave on the surface and then recursive waves gradually contracting from the surface infinitely down. So this in essence shows that, if you have a circle that's 5-inch diameter on the surface and it's being propagated or sent down this virtual timeline infinitely, and that if each stage contracts it at a certain rate as it goes down the infinite timeline, and we can come in to understand how this relates to the inverse square law, the golden ratio, and the pi. So the timeline is centered with the volume of information on the surface. So this shows that ultimately, if the 5-inch diameter circle here is propagated all the way down the virtual recursive lattice, that ultimately this says that there is no limit to how small an object can become. And we've learned that from a physics standpoint, no matter when we think we've reached the smallest aspect of the quantum or smallest aspect of the mass world, once we get better instrumentation and magnification, we can see that it seems like that size, as whether it's big or small, is precluded as relevant. Size apparently, or dimensions, or the size of a point, can infinitely go smaller and smaller and smaller. And that's what this model is demonstrating. So while all other expansion or contraction occurring in the interior represents the expansion and contraction of each slice or membrane existing on the timeline. And of course, each individual membrane is separated by what we'll refer to as the phase space, virtual phase space. In other words, if the phase space between each membrane is lengthened or extended, then this pushes the membranes farther from each other. And we can equate the pushing of membranes from each other as the extension of the timeline, or the pushing of the arrow of time toward the future. However, if we also take that phase space and contract it, or if we take the distance between any two membranes and bring those membranes closer, which of necessity means that the phase space or the distance between them is narrowing, then we can see that also that by this contraction of the virtual phase space, the timeline will reverse. Instead of being pushed toward the future, if for some reason it was reversed, the arrow of time was flowing back toward the surface, then the phase space would be shortened between membranes. And of course, this pushing forward and pulling back toward the surface is what creates the different intensities in the frequency and vibration of each individual membrane. We can say that if the phase space is pushed, if phase space is pushed or added into the system, into the recursive system from the surface, then that's going to, in essence, units, when a certain volume or unit of phase space is added, then a new membrane is entered into the system. And we'll get into the Planck's constant and Planck length and all that as related to this phenomenon. So we imagine if the phase space is increased, and we can infer this just from having a knowledge of physics and second law of thermodynamics and entropy and all of those things. If we bring all those things into view as we're considering and watching this system, then we can actually say that the increase in the phase space, or the increase in the virtual distance between membrane to membrane, would mean that the membranes are getting expanding. If the phase space is decreased, then we can say that information is being taken out of the system at the surface. And that would mean that the membranes, if the arrow of time is reversed and starts going toward the surface, then the membranes will get smaller as they get closer to their singularity, to the center of the volume of information on the surface. So the intensity of frequency of vibration occurs due to renormalization that's happening inside the virtual recursive matrices on both sides. And this intensity of vibration, or these changes or renormalizations or reshiftings of positions between the phase space and the membranes, determines at any given state of the experiment how fast, how vigorous the vibrations will be. If you can imagine a membrane that's existing five layers of recursion from the surface, it will be vibrating stronger and more intensely than a membrane that exists millions of stages down. And if you draw that fifth membrane even closer, it'll get more and more vibrating. If you add phase space, then not only the adding of the phase space caused this membrane to expand and therefore not be so vibratory, but that also indicates that another membrane is being added into the system. So that kind of yin-yang effect of phase space increased or decreased represents the addition or deletion of information from the surfaces of the black holes. So how intense the vibration of any particular membrane is measured is determined by how close the membrane is to the surface, or how close it is to the real energy reflecting to the screen and as existing apart from the surfaces.